Now, Professor JeongGil from the School of Integrated Technology, Yonsei University, will moderate the fourth session. The session's title will be Information and Communication Technology Systems in the Age of Aging. Professor Ko, the floor is all yours.
Thank you. And welcome back to GEEF 2022. My name is JeongGil Ko. I'm an associate professor in the School of Integrated Technology, College of Engineering here at Yonsei University. And today I'll be moderating a very interesting panel session called ICT Systems in the Age of Aging. So as the title of the session suggests, we will be discussing issues on how information and communication related technology is lacking or keeping up with the needs of the elderly population. And the goal of this panel is to discuss and throw to you some new directions on how we can advance elderly population-friendly ICT technology. So I have with me here today, virtually, a wonderful group of panelists. Let me just start very briefly by introducing them to you. Professor Cecilia Mascolo, professor at of Mobile Systems at the University of Cambridge, UK. Thank you very much, Cecilia, for being here today. Professor Jie Liu, from the Dean of AI Research Institute at Harbin Institute of Technology, Shenzhen. Hello, thank you for joining us today. Professor Moon Choi, Associate Professor at the Grad School of Science and Technology Policy at KAIST. Hello, thank you. And Professor Sozo Inoue, Professor of Kyushu Institute of Technology and also the CTO of a very interesting startup, AutoCare. Hi, Sozo. I'm pretty sure you'll talk about your startup today as well. Yes. Yeah, so we have four wonderful panelists today, and so without further ado, I'd like to start off our session with some initial remarks and or very short presentations from each of our panelists on their experiences and perspectives on how information technology is evolving, either in the direction of supporting the elders or in a rather unintended different way. So we'll start off with Professor Mascolo. If you can share your screen.
Yeah, thank you very much. I wanted to first thank you for this invitation, and I'm very happy to be here, even if just virtually. I will now share my screen. Okay, so in this time, we see that lots of us have already commodity devices that we carry around throughout our day. And these are phones or even, smartwatches, and they contain a number of sensors. So one might quite arguably say that we are done with this technology, and that for us researchers, there's not much to do, and that this will help the population aging and the monitoring of their behavior. In reality, what we see is that often these devices are very much scratching the surface of what can be done in a very superficial manner. And there is still quite a bit of research to be done to make this, monitoring of our life as we go on with it, a reality. A few examples of this are sensor modalities. We haven't quite yet tried to really push the envelope and try to see what we can do with some of the sensors. So this is, or even just a combination of sensors, so multimodality. And also, often we are concentrating on determining characteristics of our behavior just as a spot check, because this is what we've been doing for health and well-being. However, the continuous feed and the longitudinal feed of this data is an unprecedented mode that clinical research doctors are not used to have, and therefore the mapping of that to our health is a difficult thing to do. Also, the tests we've done with this technology are always somehow limited to very confined and specific environments. And so free living data that allows us to assess what we can say in reality is not something we've seen much of. And I'll talk more a bit later about uncertainty estimation and the fact that we rely very much on accuracy for the analysis of the data, and sometimes being able to to say if the AI system is uncertain would allow doctors to intervene and be in the loop and have a sort of clinician and AI system together. And then the elephant in the room, the fact that this data, especially if it's about us and how we behave, is a very private, very important and sensitive. And as a systems researchers, I always like to say that perhaps the computation of this data we really should push for this computation to happen very close to the user. So many researchers are trying to push various technologies so that this happens. So one example I would like to give of how difficult these things are and how important they can be is cardiorespiratory fitness. Now, the way we measure it these days is really mainly for athletes, for people that are fit, and we do it through exercise stress that puts us at the limit. And this is already very difficult. It doesn't scale. You have to be on an environment like this, artificial environment. There start to be wearable data, the wearable proxies of this, but often they ask you to do that. We only can do it when a person is exercising. And that means that we're cutting away a whole population of people for which fitness and prediction of fitness is very important because it's linked to cardiovascular health, and cardiovascular health is a very big cause of mortality. So being able to do it in the wild and do it for long and do it for the whole population is a very big challenge. The diagnosis of machine learning in clinical is also linked to this concept of accuracy, as I mentioned before, but being able to say something about uncertainty is also very important. This is a paper that, as an example, is a paper on imaging that is essentially saying that they used images of the retina, of the eye, and they computed the uncertainty of the machine learning results and allowed to refer a subset of difficult cases for further inspection, allowing for a model where the AI system is kind of co-living with doctors and they're using each other, which is great. The problem of the system for devices is that these uncertainty estimation models are very compute hungry. And so the next challenge for us as researchers in computer science is how we fit them practically on a device. The market is growing in terms of modality. I talked about multimodality before, and I talked about watches and phones. The one thing that we're really targeting is seeing what can be done and how much we can push for wearables. And the market for wearable for the ear is really growing. People are using it even to monitor their sleep. So they're getting comfortable for us to use them even in bed. And just finally, just to say that we are using a lot of devices, sensors such as the microphone to understand more about our health. We do it in the ear, and you can read the papers. And because it's topical these days, we're also trying to use the audio of the phones to detect COVID symptoms and COVID progression through the voice. If someone coughs, when someone breathes, and when someone speaks. And with this, I would like to end my contribution by thanking all my collaborators and thanking the audience and the people who have invited me. Thank you very much.
Thank you, Cecilia, for sharing your experiences in designing various wearable or sensing systems for healthcare. And I think we can use this as a basis of our discussion as we progress on. So next, Jie Liu, Professor Liu, would you like to share your perspectives?
Yeah, thanks, JeongGil. I don't have slides, so thanks again for having me here. I think I'll make 3 points based on both my thinking and some of the work we're doing regarding ICT systems in the age of aging. My background, like Cecilia, is a lot in the areas of sensing and IoT and cyber physical systems. And these days, I also do quite a bit of AI, organizing an AI institute, which is a multidisciplinary institute across several departments in the university. The way I look at how technologies are changing and how societies are changing, I think in general, technologies are moving much faster than people cognitive capabilities as people age. And from that perspective, I think the first point I would like to make is, in fact, technologies are helping us to better understand why we age and how we age. In the sense of we have new sensors, new network technologies, computational tools, both in terms of hardware and algorithms, that allow us to better instrument and collect and analyze data around people. And understanding how and why people age is a very challenging problem, right? We have only very sporadic data in the past that we try to understand, for example, how brain ages and how muscle ages and movement deteriorates and so on. But now with these new capabilities, there's hope that we can do much denser and long and multimodality data collection around people, both physically and psychologically, and try to understand the process of aging. I think we are seeing a lot of recent advances in terms of understanding the brain and how the brain changes as we grow and we age. We have lots of AI tools around image understanding and detection, like Cecilia said, sound understanding, and a lot of multimodality data correlations, as well as the big data and small data analytical skills that allow us to do statistical analysis as well as personal models. I think that's a great contribution for technologies to understand people age. The second point is technologies can actually help elderly people to live and work better. This include things like robots and wearables, and service robots and companions, remote care, and a lot of things that wasn't possible or wasn't economical in the past now are entering our lives. We are seeing remote care facilities for people who are aging more comfortably at the comfort environments rather than being held in a sort of a care-intensive environment. We're seeing lots of autonomic systems that help people to move around, help people to elongate their work ages and work days. That people are leaving workforce much later than what they used to, and that again I think is the contribution of technologies, what we can do. The challenge, on the other hand, my third point is some people call it the digital divide, or the how technologies are sometimes very cumbersome to understand these days for elderly people. Now I live in China in the last couple of years with the COVID and lots of barcode scanning and building entrance and mobile phone apps and so on. They're confusing for people who are not very used to digital technologies. I see lots of examples of this kind. We see that in AI systems, because a lot of data are collected, like Cecilia made the point, are collected around healthy, young, and internet active people. And these data and model doesn't represent the lifestyles and digital traces of elderly people. And we see mismatches between the AI capabilities and what people really need and want. For that, I think we're doing something we'll call ambient intelligence and try to create an environment of technology that embedded into the environment rather than people who have to actively use them and wear them, and try to get technologies to be out of the way of people. And we're looking at data sharing and privacy preserving technologies like federated learning in multiple levels or levels of abstractions, not just in the traditional sense of machine learning. Just in terms of data sharing and knowledge sharing and reasoning, we can also all use some notion of federated activities. Those are examples of things we see, try to help technology to bridge the gap between what technologies are capable of doing and the everyday life and work of elderly people. And to make a summary, I think this whole question of ICT systems in the age of aging point to a very multidisciplinary research area or research activities that is not a single thing. We need to gather together a lot of researchers or research activities in different areas in terms, including like computer science and devices and mechanical engineering and psychology and social science and so on, to try to solve it in a holistic way. And things are, all these disciplines will weave together. And in fact, the institute we're building, the AI Institute at HIT, is such an organization, and healthcare, and in particular, some of the brain science activities as one of the main theme in the institute we're building, and we hope to contribute more to this area of very interesting research and development. Thank you.
Thank you, G. So it was really nice. It was really interesting to hear you say that technology is advancing faster than what our cognition can improve, and how technology can not only help us, help assist us as we age, but also we can use the technology to understand how we age and why we age. It's a very interesting perspective. So you actually answered most of my panel questions using this intro talk, but we'll move on. So next, I'd like to ask Professor Moon Choi from KAIST. So Jay just mentioned that we need interdisciplinary efforts, and that's why we have Professor Choi here. She's in the department, she's in the Grad School of Science and Technology Policy. So I think we can hear some very interesting perspectives here. Professor Choi?
Thank you for inviting me in this wonderful event. Yonsei University is my alma mater, so I'm so honored to be a part of this the forum. And I'm a gerontologist, so as Professor Go mentioned, that my background is social science. And gerontology means that it's the study of aging process in individuals across the life courses. So we analyze the history and also social construction and social environment, how those things affect the aging process. So at KAIST, I am running a group. It's called the Aging and Technology Policy Lab. So we research about artificial intelligence and also robot, and also the public health systems, how those things affect quality of life and all the others. As you know, that Korea is very unique because Korea is one of the countries experiencing the fastest aging, also very advanced information technology. So the government has invested a lot about developing a new technology for older people, say the smart home technology, wearable device to help older others in aging place and maintain their health. But it's very interesting. I feel you probably remember this in about 12 years ago. In the public space, most people didn't have a cell phone, but now smartphone is very popular. But I've never seen any single technology that older people use like this. So the leading the scientists and engineers like this group invest a lot of time and effort to develop a new technology for older others to help their health and quality of life. But it's very hard to think out, one single technology. So I feel there is a huge gap between development and actual adoption of this new technology. I think there are 3 reasons. The first one is about stigma associated with disability. Second is high cost. Third is a steep learning curve for use. So I have thought about what I can, provide to this the discussion, and one of the important messages is about the innovation serendipity. That means that there are alternative products already in the market, widely used. For example, like a smartphone or AI speaker or etc. But they can be easily adapted and helpful for active and healthy aging. Than some senior product that we call only for older people. So age-friendly innovation happens when we find age-friendly features of existing technology, and I would like to call it innovation serendipity. So I think a very important point here is that the important message here is to create more innovation serendipity. It is very important that society embrace diversity, and also that throughout the development and deployment process of technology and relevant service model, developers need to be aware of the importance of diversity. I would like to say it's more universal design approach. So in the lab, we often see that user tasks are done only for a small group of people, and those groups are usually able-bodied, educated, and young men. So that often results in creating barriers for people belonging to other groups, say the people with a disability, or older people, or less education, etc. So I think one of the primary reasons behind the failure of many great ideas and great initiatives to develop new technologies is a lack of awareness of diversity in the process of R&D. So it's very important to create a social impact, also change the society. It is very important to think from the persons in the think in the shoes of the persons with the other social background. So I think professionals working with all the other sorts of family caregivers and older people themselves can participate in age-friendly innovation, finding some type of serendipity in available popular technology. So here are many educators and researchers at university, and I think it is very important to think from the diversity perspectives in the development of R&D. So in that way, we can change the society. Thank you.
Thank you, Professor Moon, for your perspective on how technology is evolving. Yeah, it's interesting how we say that we're going to develop new technology for elders, and we know that the elder population is one of the most non-tech savvy people, and we're always saying that we need to develop this new technology for elders, and it's kind of contradictory, but it is what we're doing, so that's why we're trying to discuss solutions here. I guess next is Professor Sozo Inoue. So could you share your slides?
Can you hear me?
Yeah, I can hear you.
Okay. Hello, everybody. I'm from Japan, and now it's the evening in Japan, and I think it's the same time as Korea. And I'm very honored to be here to just enjoy the panel discussion here, because it's pretty much related to my research topic and interest. So yeah, I'd like to start with this slide, which is very similar to the what Moon Choi presented, but this is a ratio of the age over 65, and as you can see that Japan is the top Olympic in the gold medal in the top. But many other countries are. The important thing is not the ratio, but also the slope of this graph. Because if we are aging very rapidly as a society, then the social systems will be very tough to catch up or the support the elder people, right? So in Japan, we are also deploying, or we are increasing the, how to say, intermediate or the middle level care services between hospital and the home. So which we are saying that like the caregiving facilities or something like that. And in there, so as a cost of the social cost, maybe the hospital is large, and if the people are at home, it's not so big, but it's intermediate if we give the caregiving facilities. And also the goal of that kind of the services are a little bit different, because if you go to the hospital, the goal is to cure the diseases. But if you want to be at home, then we want to be well, be like a well, or we want to spend the well-being, or get well-being, as well as we are when we are in the caregiving facilities, because the elder people are not only with the diseases, but they are healthier, but they want to spend a very good life. Okay, but we are facing another problems here in Japan. So that means that we need more, professional caregivers, and we are increasing this kind of the requirement, and it will happen also in any other in the world. So we are also expecting the very much missing number of the caregivers, and so we. In my research, because we are doing the human activity recognition technology, we want to utilize this technology for helping that kind of the requirement. So human activity recognition means that if you have, so this is related to the Cecilia's talk, but if you have a smartphone, then we have sensors inside, then we can recognize what she or he is doing right now. So this is the technology of the human activity recognition. So at first we try to recognize and see what is happening inside for example, in the nursing work in the hospital. Then we found that they are very busy at work, but as well, they are also busy in recording their work, because they have to record all of their medical records or something like that. So it is taking already a very long time. So we also understood that this kind of technology is or the IoT or AI technology is very important to also reduce their working load for recording, as well as nursing services. So we also try to do apply the activity recognition and integrating it to nursing care records in caregiving facilities. And we also developed some of the system to help them to easily use this kind of the data collection as well as the sensing. And of course, you may, we cannot see the operator, but she is also a senior, like a 60 to 67, 65 years old. And also the professional staffs are already not yet skilled for the user, system usage or something like that. So the user experience or the user interface should be also very simple and very, simple and easy to be deployed. Okay, so we did a lot of improvement on this system. For example, that we press the AI button, and by using human activity recognition, by pushing the AI, then we suggest the input of their records, or even we also introduce some audio input, like if we talk that to the system, then it will automatically select the options, or even in the text choice or something.
突起事項は特にありませんが、スポンジブラシ使用です。
So by this kind of the input technology, it becomes very easier to do something like the data analysis, or develop the AI or something like that, because it is already structured, and it is also very friendly for the data science or something like that. So this was our product, and we started a new company, which is called AutoCare. And right now we are trying to deploy to help the aging societies in the world. But lastly, I'd like to introduce, or I'd like to raise some points about how to deploy this kind of systems or this kind of the new technologies. So one new challenge here is that when we talk about the traditional IT systems and how we design, or how do we develop, is that firstly we make a specification and implement, like a programming or the coding or something like that. Then we will check it if it is as specified or not. But right now, when we use the machine learning or AI or that kind of things, so the things will be a little bit complex because we have to train the model or we have to train the AI by using data. And in that case, so we cannot trust the system until we get the real data. So this is one of the engineering problem, but also that as for the system deployment or something like that, at first it is, something, it is called like a cold start problem or something, but we cannot make the system available at first for the aging or the new world or something like that. So this is one key challenge, I think. So this is the last slide. So my last message is that right now we are in the world of the digital transformation, which means that everything is going to the digital, and every business or everything is built on the digital basis. But I think as well, I think it is very important to think about the experience for aging society or the aging people or the professional people for the aging services or something like that. So this is the last slide. So thank you very much, and I'm excited to be here again.
Thank you for all your presentations. It was nice to hear all your different experiences related to systems that can assist the elder population. So let's try to jump into some discussions here. So based on what we talked about right now, so at least you or we have some experiences in designing systems for the elder population. And we've been designing lots of different sensing computing systems for in general, but how do you think that how do you think we're headed, right? I mean, in general, do you see the technology development path going into a direction slowly or in whatever speed in a direction where we can support this less tax-heavy population? What are your perspectives on how the ICT technology in general is developing over the last few years? I think we can start with Cecilia, if you have any thoughts.
Thank you. I mean, from my perspective, I see that the technology is becoming a little bit more seamless. Small steps. We are seeing, for example, example of technology that does passive sensing and tries to infer behavior by observing with the sensing, which means that there is less interaction with the user. So if the user has that device somewhere, either on the body or in the house, then the technology is able to infer. One example was, in fact, shown by one of the other panelists. There was one of these home devices, home speaker. So speaking and interacting with the voice could be, something intuitive, something that people do with other humans. So that could be a way in which I think we have progressed. And also from my research perspective, beyond that, from that voice, you can even try to understand not just the words, but also perhaps if the person is stressed, or even other, there's been links from voice to psychological diseases, but also to Parkinson, to cardiovascular even. So I think that's very promising. And devices are becoming more and more wearable in a seamless manner. Tattoos, fabric are coming, and this could lower the entry point, the more seamless it is. And obviously the user interface needs to be fixed, but yeah, that's one way I see. I'm not sure I'm answering.
Any other thoughts?
So, if I may, I think I totally agree with what Cecilia said. There are technologies that are much better suited for elderly people to interact with and to use. At the same time, I see the challenge of not all interfaces are designed for elderly. They're much faster and greater number of apps. Those are took for granted, right? People like the font size, that's just as simple as that, right? the interaction habits and those type of things are designed without taking care of thinking of the elderly users. And sometimes those things are useful and popular and become part of people's everyday life, and just for some people just got left out. I think we, in general, just in terms of the design, we are thinking not as much as we should for the aging population.
Yeah, I fully agree. And another interesting point that I thought, I guess, related to what both G and Cecilia mentioned is, even if we have these, verbal interaction mechanisms, the way that the younger generations actually talk to those speakers and the way the elders actually talk to those speakers, the way they interact can be fairly different. So, and I'm not sure if technology is really ready for that. Yeah, but Professor Choi, do you have any comments on your perspectives on how technology is evolving?
Yeah, about 20, 30 years ago, most of the technology for all the others are very much about health sector. So it's about more medical technology or, promoting health. But these days, the primary purpose of technology is more about social participation. It's beyond the health issues. So I feel there are more diversity in terms of their primary goals. And the second is that I think it is very important to think about the generation differences. When you think about older people, it seems like there are certain group of people who are always static and never changed, but actually it's not, because I'm quite different from my grandmother. So, future older adults would be quite different from the past older adults. So based on the research of our group, the baby boomers in Korea are quite different from the current old adults. So baby boomers are, late 50s and early 60s, and even some of them are, over 65, but they are quite different from 80s and those in their 80s. So it's very important to consider the cohort difference or generation difference in designing technology, because the future older people are quite different from the current one. So that would be the important thing. Yeah.
Mm-hmm. Sozo, any thoughts?
Yeah, I would like to talk about the human related things or the population kind of things. I think that, of course, technology has developed so fast in the recent years, because, for example, iPhone born in 2007, and before that, nobody had seen the, the smartphone. But right now, everybody's have seen smartphones, right? So it's very rapidly developed. But I think I observed one thing is that in the last decade, we became very easy to, move virtually or connect geologically. I mean, that we can meet from everywhere in the world. But it may be becoming a little bit difficult to communicate between generations, but between ages. Because, for example, I use Facebook, but my kid doesn't use Facebook. So if I send a message to my kid, then my kid doesn't read it. But if I send it by using Instagram, then my kids read it, or something like that. So some of the gap between generations is happening right now and becoming more difficult to communicate each other. So this is my understanding of the general problem of the aging society or something. So yeah, and so if we can overcome this problem, then we can communicate with every ages. So this is my perspective.
Yeah, very good point. I mean, if we can overcome that gap, then we have a solution. The problem is how, right? So I think Professor Choi mentioned that this when we typically thought of technology for the elders, we used to constrain ourselves to healthcare applications. But as G also mentioned earlier in his talk, with this COVID-19 business, it's, smartphones to do everything, right? Smartphones to enter a building, smartphones to, I don't know, whatever, order food, right? So given that, now we're really looking into ubiquitous technology coming into our lives, or unavoidable ubiquitous technology coming into our lives, you know, what would be some really first steps that we as researchers, or for some of you with commercial sector experiences, can take to actually kind of bridge this gap that we have between generations and the challenges unique for the elder generation? Well, what would be our short-term goals that we need to shoot towards to make this technology really easy to access? It's a $1 million question, I know. G, you have both experiences from the academia and the commercial sector, so maybe you can kind of share your perspectives here.
Yeah, that's really indeed a $1 million question. I hope I know the answer. It's very challenging. I think just in terms of as the example you talked about, JeongGil. Let's say just an app that's allow us to enter building and order food. I personally experience from people I know, for example, mobile payment, which is a new thing. A lot of elder generations are used to cash or maybe even credit card was a new thing. Mobile payment, after some training and explaining, and they can understand, but then the flip side of the coin is people take, there are quote unquote bad people taking advantage of elderly people who don't totally understand or completely understand the technology and try to trick them, right, to do some criminal things in terms of getting their money out of their bank accounts and so on because of the passwords protection and things like that. So it's not just we try to make the technologies or try to educate people to use these new technologies, but also to educate them to understand what's behind it and all the logics and rationales of why do we have password, why the password has to be sophisticated enough for people to not be able to guess it, or don't tell people your password. Things like those type of things are, it's a very holistic thing. It's not just one activity that you introduce will unlock a whole chain of things, because we are piling up our technologies on top of each other to get to where we are, to get the convenience we have. I don't have a, I really don't have a silver bullet here. The only thing I can think of is to both educate elderly people to make the technology simple enough for them to both interact and understand, but at the same time to raise the bar of these app developers and the app store, the gatekeepers, such that the app that we're experiencing, especially the critical ones, are well protected for these elderly people to use.
Yeah, I think that was a great perspective. And even in Korea, when we started vaccination, one of the things that happened was we started with the elder population, but you needed to reserve your vaccine using your smartphone. So the only people that could actually reserve the vaccine at the right time were, you know, people that were actually good with using a smartphone, or had kids that, you know, could use a smartphone to help them out. And this was a problem at some point. And I'd like to ask Sozo on your perspective, since you're actually designing these apps so that elders can easily access the capabilities on what efforts you're putting into to actually, you know, get these apps elder friendly, or adult friendly, elder friendly.
Okay. So what I experienced from my product is that even, you know, very super good, super high tech or super good product, it is not it will not be used until the user feels it is good. So that means that we need to, not only design a good product, but also we need to design the experience of the users. So let's think about, my younger age. So when I was a kid, I could use, I had a chance to use computers or something like that. But right now I'm thinking that I could do that because I had some, person who are very good, or who tells me everything when I ask about the PC, who was my father. But even if in my case, so if I'm facing in a new technology or new system or something like that, so if you have some good person in front of you that who can answer anything or who can tell anything to you, then it is we can have a good experience. Then I think that we can be able to feel it is good or it is fantastic or something like that. So it might be related to the Moon's Cho's comment as innovation serendipity or not, but yeah, I think that this is related. So yeah, this is my experience.
Cool. So I'd like to pass the baton to Professor Choi, because I'd like to hear a more social science perspective on this, on how we can approach this, because most of us here are engineers, and it would be nice to hear how you believe that social policies or in those retrospect can assist the technology advancement for the elder population.
I think the future technology for the aging population would be about the transformation of sensing. I feel these days most of the communication is based on vision, so eyesight. But when we get old, we become have poor eyesight. So it is very important to transformation between sensors and sensings. So, for example, sound could be transformed into the text or touch. So, because we have lots of different sensors in our body, but I feel we overuse our eye. And also, most of current ICT technology is so much about vision oriented. So, if the engineers or computer scientists can easily transform, different format of the sensing, it can be a very innovative. So for example, text to speech or auto transcription, help people with vision impairment or hearing impairment can access certain information. So I think in the future, when you get old, we might lose certain sensors of our body. But if we can use other sensors and that easily navigate the information, it can help us to expand our the digital the environment, and also the ICT can help more wider population. I believe so. Yeah.
So sensory substitution, I guess, like I know we get old, our eyesight gets worse, and you have something else to substitute that. Perfect. We have the multimodal sensing expert next, Cecilia.
Yeah, it was like feeding ideas to me. Thank you for that. So in addition to substituted sensing, I think there is the obvious other thing, which is passive sensing. I mentioned this before, but the expectation that a user needs to input data is not always true. Sometimes that data, the better we get as technologies in inferring data from passive sensing, this could be from devices we wear, but also from contactless devices, the devices that are around us. As I mentioned before, smart speakers, but also there is now technology developed that is called contactless, and it sends signals on your body, and then the reflection of that signal allows you to understand heartbeat, for example, stress related physiological changes. So I think in an aging population that would help a lot. The other consideration, perhaps I'm an optimist, so you have to indulge in this. We are aging with the technology. So if we're able to consider that, you know, a 60-year-old is someone that has been exposed to a smartphone in let's say, more developed country, in rich environments, in certain kind of the senses, it's been exposed to a smartphone for a long time. So we could develop diverse technology that is already, you know, they're already quite advanced, the 60-year-olds, right? So our 80-year-olds in a couple of years will be able to deal with technology that we are not considering now. So our job might become easier in that sense, but we need to consider that the 20-year-olds will have even newer technology. But there is still the technology that is quite robust and quite useful. So yeah, so that's a little bit of a mitigation. Thank you.
Yeah, so I like that term. We're aging with technology. We have some hope, right? I know how to use a smartphone now. I probably know how to use a smartphone when I'm 65. So I guess that's the hope that we're having. But the downside, or on the pessimistic side, you know, heaven knows what technology we will have in 30 years. Will we be able to adapt to that technology? It may still remain a challenge for us to address. So we don't have too much time, so I'd like to just hear maybe some last words that you would like to share on, you know, so the whole point of this forum and this session is to put awareness to the audience that that ICT technology, yes, evolving in a direction where we have faster systems, more high throughput is great, more applications, great, but can we go in a direction where we can actually cover a wider population, cover the population that really needs support from this technology, and just opening the awareness for such needs. So if you want to share some last words, please do. I think if it looks like, I don't know, I'm looking at the screen, maybe Sozo's ready.
No, I have a lot of things that I want to talk about. I need to talk for 1 hour to share with that. But listening to everybody's talk, so I was also I felt very informative. And the one thing that I felt still it will be a challenge in the future is one thing is that to capture the attention or intention of the human will be still challenging, even though if you use many sensors, maybe. And maybe this is very much different, that the difference between that, okay, I want to do this, or it was sensed like I'm behaving like this. So this kind of passive or active things is very much different. And also because the human should be centered, so humans' intention or humans just passive sensed things will be very much different in also designing the system, and also evaluating the system, or also to deploying the system, or making the value of the system increasing. So this is the first point. And I was also looking back some 10 years ago that when I was doing some large experiment in Bangladesh. And Bangladesh, at the time I was doing some health checkup using remote sensors or something like that. And at that time it was very much special experience, because they were using, at that moment, they were using not a smartphone, but they were using cell phones. But the point was that there were no power supply. So it was very, as from the viewpoint of some infrastructure, it was very funny for me, because there was no power supply, but they have the solar power charging system. And then they can charge the cell phone, and they could talk by using the mobile, mobile station or something like that. So it was very much very surprising things for me. And right now, if you go to Bangladesh, everybody is using smartphone, of course. So maybe in the 10 years or the 20 years after, maybe the world will also change, and we cannot expect what will happen. And the important thing is that we connect together and also, see what happens, and also we can, discuss what will be the goal. Okay, so this is.
Must be a really hard topic, right? I mean, we got to see what happens, right? Professor Choi, any last minute comments you want to share with us?
Yes, I feel, these days engineers are more influential in society. So they are people who, design the systems. So I think it is very important to educate, the future engineers and computer scientists as well. And recently I read an article about embedded ethics. So at, MIT, they included the week or the module in all the classes for 16 weeks. So they included the ethics, curriculum. So I think it is very important to help, the student to think from the diversity perspectives from the undergraduate, graduate school. But it's harder to create a new course, but it is very important that curriculum would be integrated the entire course. So I think that would be the very important the initiative to achieve the SDG, because this forum is about the sustainable development goals. So it is very important to, we keep our eyes on the education curriculum and, help people to get better insight about the society. Thank you.
Great. Education, very important. G, want to share some last words with us?
Yeah, I think, JeongGil, you hit the nail on the head by saying the word awareness. I think that's probably the first very important thing or step that we should take to actually have people understand and be aware of how the technologies are serving or disserving the elderly population. I can imagine in middle school classes or college classes, you have these devices that you wear to let you know how you feel like being elderly. You're losing eyesight. You can't hear very clearly. You can't move very easily, and then people get the sense of what technologies and how technologies can and cannot help the elderly people. I think just a fun thought on that. So awareness is being number one. The second one is the market force. The economic force is much more powerful than any talks or policies per se. And I think as the aging or elderly population is going to, I believe, 2 billion across the world, and they are growing up with more of a digital awareness, I would hope that there'll be enough market power and purchase power for them to drive the force of technology savvy or developers who's going to develop new things for them, and then as a result that serves a lot more people in this population. Those are my two thoughts at the end.
Thank you, G. I have a 1 minute 50-second clock ticking in front of me. Cecilia.
Okay, I'll be quick. So to me, it's the reliability of the technology. The fact that we use it for our health and our well-being means that we need to make sure it's right. And we're pushing technology out commercially that we don't trust. I mean, I can show you a graph of my sleep pattern, and I know I was awake at some point. So, there was a mismatch. So we need to work on this. This can be done in 2 ways: improving the precision, and that's very hard and requires probably costly as well. The other way is developing some sort of, as I was mentioning before, some uncertainty estimation, give the user the idea that actually we're not sure about this sometimes, and maybe work on it. And if it's something that needs to be assessed clinically, then having that relationship with the clinician and have that in the loop. So I think these things are very, very important for the technology to be reliable. Otherwise, people will throw it away.
Okay, thank you. Thank you very much. So thank you very much for all 4 panelists for joining in today and sharing valuable perspectives on how ICT systems are evolving and how we should evolve towards the future. We don't have answer. I mean, if we had an answer, we wouldn't be here. We'd have better things to do. But I think it's meaningful that we let people be aware of the fact that we need to care about this, these different populations that are not, teenagers that know how to post everything on Instagram stories. And I hope this panel was a nice initiative to start such type of awareness. So thank you everyone for being here today, for talking, and thank you everyone on YouTube for watching. Thank you.
Thank you.
Thank you.
Thank you, Professor Ko and panelists, for sharing your insights about how technology can be used to embrace the elderly into our society by empathizing with their needs. Now we will take a break for 15 minutes and resume at 6:45 p.m. Korean time. Thank you.